Hey guys, just wanted to do a video. I've been doing a lot of bench testing on different things. There's a lot of times I don't show the experiments that I do here at home. Most of my videos are just the spinny spin videos. But I wanted to share the experiment that I've been doing working with the output of my wind turbine motor. So the circuit we're doing today will demonstrate the transfer of power from one set of caps into a single cap. I've got 9 40 volt 3600 UF caps paralleled, and we're going to be charging one single 40 volt 3600 UF cap, and between the two positives we will be running a choke, which will be the license plate light in series with the transformer that's in series with the motor that's in series with this transformer that's in series with this wind turbine that's in series with this motor that runs over to the positive of the dump cap. And on the negative side, we have a coil that's in series with the LED light, which the positive goes to the negative of the charge cap, so that the LED light will show us flow between the two systems. When the two caps equalize, the LED light will go out. This is the LED light that'll be on. But I want to show and demonstrate today that on your high side of the circuit here, if you have a high voltage with a very low potential on this side, the work that actually can be done, as in magnetic field and usable power, is greater than what is transferred. I'll demonstrate that we can create a magnetic field and trigger the relay that's in the circuit here with less than a half a volt transfer from cap to cap. I'll show how you can just reuse the dump cycle to the beneficiary of the motor, because it does produce a magnetic field. It doesn't push the wheel real hard here during the transfer rates, but the relay shows that there's a magnetic field there. So if the magnetic field is in the relay, it's in this coil, this motor. Every coil winding that's through the system is generating a magnetic field. So let's just kind of get up here on the bench so I can explain more what I'm doing. These tests are based off of a few other experiments that other people did. The what if I did this channel, did the circuit with the AA batteries transferring through an LED into some parallel AA batteries, and then was able to swap them back and forth, reusing the power to keep the light lit. My experiment is based more off of RWG research, the Search for Answers series that he did. I think it's video 5. This is where most of my experiment is led through what he demonstrated on the bench test. If you watch the video, go about 24 minutes in, that's when the bench testing stuff starts. Watch it, kind of just think about what he's doing, and then imagine just doing it on a larger scale. So the experiment here will be, we are going to transfer from the high side of the circuit over here to the low side of the circuit, which is the secondary capacitor, and we'll show the magnetic field that is produced during the transfer, putting the coil in series with the transfer. And I have a theory and can kind of explain what this phenomenon is and why it's happening and how we can use it for our benefits on our pulse motors. You'll have to see. So right now the cap is 20 volt. Let's see if we can make sure it's in the camera. We're just going to use the pulse motor to pump the initial cap up here. These caps hold 40 volt, so we're just going to go ahead and take it up to a little over the 40 volt. Alright, we'll stop the pulse motor so there's no extra input into the caps. So our charge run caps are currently at 41 volt. It'll slightly drop, it'll bleed off a little bit. Our dump cap that we're going into has less than a volt in it. Everything is running through the chokes and the lights. The circuit is open currently. I'm going to do a sharp contact with the wire and release. So we transferred under a volt. Got a reaction from the switch and the light lit. Do it again. See if I can get it in here. Just going to make a quick contact to make the contact for the circuit. Still under volt transfer rate. The relay triggered. We transferred almost nothing to the cap from the main source. But the moment that the circuit was made, the magnetic field was present. I'll do it again. Still under 1 volt. Transfer. We'll do it again. Now we're over a volt. Still 39.5. Oh, it shorted it. Do it again. If there's a magnetic field in the relay that makes it trigger, there's a magnetic field in that coil. There's one in that motor, and that transformer, that motor, that transformer. So there's a magnetic field present in every one of them. For almost transferring no power each time if the contact is made clean with whatever switch was used. This is a very easy experiment that everybody can do. And then I just thought it was amazing that the magnetic field appears before current even flows. So if we was just pulling off our output of our motor while the motor was running, how many times can you run your coil on your motor before your tank gets full from the transfer rate? So we're at 32 volt here, 10 volt there. If I just do a dead short and let the transfer rate happen, everything equalizing. This should prove that if your motor is a high voltage, low amperage output, that the output of the motor can be discharged through your driver coil into the low side of the circuit, getting the magnetic field for absolutely nothing. It takes very low amps to make the alignment in the wire, and you can blow the field up with volts. So your high side of your circuit versus your low side of the circuit is all about how much pressure is on the high side. Because what people don't figure is you're like, well, you're only transferring a tenth of a watt of power. Well, what we're not factoring in is the speed of the electricity. So when it goes from the high side of the circuit to your low side of the circuit, it doesn't matter if it's 100 volt or if it's a half a volt, its speed is constant across the system. The speed of that half a volt moving across the system produces more of an electrical field than you could even produce with the voltage that was transferred. That's the biggest thing that I see with this circuit being used for induction and inductors for a system. Now, if I discharge this system correctly, I do produce enough magnetic field in this coil to move this 20-pound rotor a little bit. So it would be to fine-tune what your choke would be for your drive coil, and you would need the high output to be able to transfer unlimited electromotive force on a machine by just discharging the output. The output would be all free, and the motor should run from the discharge of its output, if that makes sense. So we're going to do it again real quick. I will discharge these caps. If I can find my discharger. I'll just use a screw. And so our discharge caps are under a volt. We'll just charge them again. Bring it down to nothing. Use pulse motor to pump the fucking caps up again real quick. Now caps are full. Stop the pulse motor. Caps are at 42.6. Secondary here is millivolts, under half a volt in the caps. Do a quick sharp transit discharge. No transfer, but the light lit up. No transfer. almost no transfer. That's a pretty big magnetic reaction for almost no transfer of power from one vessel to the other. It absolutely has to be created from the speed that it travels from one to the other, no matter if it's a half a volt or 100 volt. Although maybe more pressure make it go faster, bigger hill. See, we transferred almost nothing in this. You're triggering the relay. We'll see if we can do a straight discharge to see if we can see movement on the wheel. The wheel did move. We only transferred 6 volt. We'll leave it on. It seems like the more choke I put on it, the less drag I'm getting on the motor for the charge caps too. Now I'm going to just discharge the cap while the circuit is connected. So we'll discharge this one, and this one will run to end rush into this one. Long delay. Super long delay during the discharge process. I mean, I haven't showed that as the flow stops between the two sets of caps, the light goes out. But as the flow is heavy between the two sets of caps, the light is really bright. So that's where it would play into, what if I did this as a circuit, would be that the LED stays lit as long as there's flow between the two. The bigger the potential difference, the better. My voltage drop doing a dead transfer, we'll show that now, I think. How much of this voltage-wise will transfer into the single vessel. If they're both paralleled, the readings should be equal, but the readings aren't equal, and it's because of a siphon effect, which is very interesting too. We'll pump it up real quick. Stop it. I'm going to discharge the cap. We'll turn the switch on and we'll do one full transfer from 41.5 volt into one single cap. The transfer cap got 19 volts. So yeah, they should have equalized half and half. Be like an air tank and a flat tire. We'll demonstrate that one more time. I'm going to sort the caps out. Nothing in the cap. Pump her up again. Bastard. All right. No extra input. Do one hole transfer. So that time it transferred almost 19 volts from 40. And we produced a magnetic field. I don't know, maybe I could do a cleaner demonstration later on. I figured I'd share that you can create a magnetic field for almost transferring absolutely nothing into a set of caps. There's more energy in the energy racing across the wire to the other side than there is in the energy that you're transferring. Well, thanks for watching, guys.